Hello, welcome everybody. Hopefully my mic is on loud enough here. Let me know if you can't hear. Thank you so much everyone for coming today. We're really excited to bring all of your diverse and brilliant minds together towards working on the problem of excessive infant crying. My name is Paige Sorensen. I'm the manager of the Team Science program in the Research Development Office here at UCSF. We do things like this event to bring people together to build collaborative teams. And we also have several other programs in our office that are listed on this slide that's been looping. So I'll let you take a look at that for just a moment while I introduce what we're going to be doing today. We are going to have a few lightning talks by our distinguished speakers who will then lead discussions at these 4 tables that are set up here. So after our talks are done, we'll have everybody in the back come and join a table, and we'll have some group discussions around specific questions, and then we'll come back together for discussion reports and next steps, and then we'll have a little networking reception for everyone. So without further ado, I'll introduce our first speaker, Dr. Amy Gelfand.
Thank you all for coming, and thank you for the people who are here in person, but also we are live streaming on the web, so thank you to our attendees who are here that way as well, and thank you to our Team Science program and Paige Sorensen and the whole group for putting together this wonderful event. We are here to talk about infant crying, and I think it's really interesting how little we understand about infant crying. This is a behavior that's displayed by all babies, and we really don't understand why they're doing it, what the different kinds of cries might mean, why some are crying more than others. And that's just in our healthy, otherwise typically developing babies, in our prematurely born babies, in babies who have acquired brain injury or whose brains developed differently. That adds a whole additional layer of complexity that really highlights how little we understand about what's happening with crying babies. So my interest in this particular area is in fussy babies, sometimes called colicky babies, babies who are crying excessively. And we don't really know why some babies cry more than others. Certainly all babies cry, but some really make a grandstand of it. And it's clear that caring for a fussy baby can be distressing for caregivers, it can be frustrating for caregivers. And while we don't really know what causes what is sometimes called colic, but I prefer paroxysmal fussiness of infancy because that name colic implies that there's a gastrointestinal etiology that I don't think we really clearly know. Brain localization, I think, is at least equally likely. It really does matter to eventually figure out why these babies are crying so much, because the peak in hospitalizations for shaken baby syndrome comes right on the heels of that developmental peak in crying that comes around 5 or 6 weeks of life. So certainly some parents are being, exhausted parents are being driven to the point where they're losing control, and a form of child abuse is occurring. And in fact, in an anonymous survey of parents when they had 1-month-olds, 1% admitted to having shaken the baby at least once to try to stop the crying, and a little over 2% had either shaken, slapped, or smothered the baby at least once to try to stop crying. And by age 6 months, that number had increased to about 5.5%. So certainly that is a problem, and we want to understand infant crying better so that we can help support families when they're going through this rough patch of infancy. So my particular interest in this topic began when I was doing my adult year of residency training, and I was rotating through our headache center and speaking with all of these patients who had migraine, and they were describing their exquisite sensitivity to stimuli, sensitivity to light, sensitivity to sound, all these sort of issues. And it was really reminding me of the parents of very fussy babies who I had spoken with in my primary care clinic. And that just stuck in my head, and I was interested in trying to explore that more. And it turns out that there is some relationship between infant colic and migraine, but we'll come to that in just a minute, because I want to step back and give you a little background on migraine, which is that it's a brain-based disorder. It is has strong genetic underpinning. So most people who have migraine have a family history of the disorder if you take the history thoroughly. And migraine is really the quintessential feature is excessive sensitivity to stimuli. It's not actually headache. It's really this increased sensitivity to stimuli, and that can be to external stimuli. For example, the lights seem brighter than they really are, or sounds seem louder than they really are, or that can be to internal stimuli. Little movements of the head can make headache worse. They can bring out vertigo. Just very sensitive to what's going on there. And just to give you a quick illustrative example that happened in the clinic yesterday, I was seeing a teenage girl for a new patient visit. We had just started the visit. We were talking a little bit, and she stopped and she said, "What is that noise?" And I listened because I'd been in that clinic room all day. I hadn't heard anything. And it was just like a little air vent noise moving through the room. And I said, "Oh, it's just the air vent." She said, "It's so loud." And it's so diagnostic that I could have probably just stopped the interview at that point and told her what she had. But it really is clear of how sensitive to stimuli people with migraine can be. And so when I was thinking about this in relation to babies, there were already a few studies, case control studies, showing that children who have migraine are more likely to have been colicky as infants based on their parents' recall. And then we did a study that showed that mothers who have migraine are more than 2.5 times as likely to have babies who have colic. And then a larger study was done that was published in JAMA in Europe that was conducted in Europe, that again showing that children who have migraine are more likely to have been colicky as babies. But this time they weren't relying strictly on recall. In Europe, I guess they have these little blue books that all children have, and they bring them to every single doctor's visit they go to, and somehow they don't lose these books, which I think is remarkable. And they had like 98% book review on this, and again showing that children who have migraine are more likely to have been colicky. It had been written in their little baby book when they were infants. And then finally there was a prospective cohort study done showing that babies who are colicky are more likely to grow up to have migraine without aura by age 18. So there's quite now a robust mass of literature showing an association between infant colic and migraine. That certainly doesn't necessarily imply a causation, but if we were to follow that through, the hypothesis would work like this, where babies who are inheriting migraine genes from their parents, they are getting a brain that is wired up to be more sensitive to stimuli than other babies, and they're expressing that sensitivity to stimuli through excessive crying, particularly at the end of the day. And this is kind of an artist's rendition of the amount of visual stimulation that a newborn might perceive versus a baby who's a few months old versus an adult. And I think it really highlights how quickly babies' perceptual abilities are ramping up during the first few weeks and months of life. And one of the funny things about colic is that it doesn't necessarily happen right in the delivery room. It starts at a couple of weeks of life, even though feeding starts basically right from the get-go and then goes every 1 to 2 hours thereafter. But colicky crying actually tends to happen at the end of the day, late afternoon or evening, when people, and perhaps these babies, have just had enough of all the stimulation and they're just expressing that they've had it by a little bit of excessive crying. So putting all that together, my question is, if that is what's one of the things that's underlying excessive crying in infancy, can we use what we know about helping children who have migraine to help babies who have colic? And I'm not suggesting prescribing triptans to neonates, but really simple things like decreasing the amount of people in the room or turning off the lights, decreasing stimulation that's around the baby, maybe something that we use very commonly like acetaminophen, but nothing that would be really reaching the outer margins on safety for babies. And how can we push a little bit further into hypothesis testing? Well, whether this hypothesis has any legs or not, we have surveyed the parents of babies who are 4 to 8 weeks of age about if their baby is colicky or not, and if they're colicky, how sensitive to various stimuli they think their baby is versus if they're not. And the parents of colicky babies do describe their infants as being more sensitive to sound and more sensitive to smell than the parents of non-colicky babies. But it would really be optimal if we could do this in a more objectively measured way, where ideally we can capture how many lux of light exposure or decibels of sound exposure the baby is being exposed to, and then measure their crying response to that. ideally even experimentally controlling the amount of stimulus that it takes to bring out crying in a baby, which will be a fun IRB application to write. But regardless of whether that hypothesis is correct or not, in colic treatment trials moving forward, I think we really need an objective way to measure infant crying. Right now, the gold standard is what I've got here on the left, this baby cry diary, which I've called the onerous paper cry diary, which is clearly not its name. But if you look at it, you have to we have a pointer. Here we go. You have to code each time period. The parents of like little 5-week-old babies have to code each time period as either awake and fussy, awake and crying, unconsolable crying, and this is in 5-minute increments, and this is really quite challenging, I think. And then once you get that data form returned to you from the study participant, some poor study coordinator has to actually interpret these hatch marks and then enter the data, and that is just an inherently nightmarish sort of error-prone way to collect the data. And so wouldn't it be better if we could do this in a more automated fashion? And clearly this is one of those little hug security tags that babies get in the nursery, but what if we had a device that was a wearable device that babies could have on them to help us detect crying, store the data about it, and transmit the data about it? So concept, here's the baby, and this is my Fitbit that's strapped around the baby's leg. But if you could modify this to somehow detect through a mixture of sound and heart rate and actigraphy when the baby is crying and when the baby is calm, and store all that and then send it directly into either the clinician's area or into, for those enrolled in the study, into the research database, all beautifully quantified, no hatch marks, no data entry, none of these sort of nightmares. But I think there's a lot to be developed there. I really don't know how to make a device, and that's one of the things that I'd love anyone's thoughts about during the roundtable discussions. What kind of data points we need to capture? Do we need ambient sound? Do we need ambient light? What are the important things to capture about crying, and how best to put that to use? What are the really important clinical and research priorities that this kind of a device could be used for? Because I think that would really speak to what sort of funding agencies would be interested in developing it. Thank you very much. And
thank you. And next we have Nurse Judy.
Can you all hear me? Okay. Thanks very much for having me come today. I'm very honored to be part of this panel here. My name is Judy Kivowitz, and I'm the mother of 2 kids. And for all of those of you who have managed to get through the crying babies, they grow up to be able to help you make slides for presentations like this. Because when Paige told me I had to make slides, I was like, call the kids. I've been a nurse since 1981, and my first job was actually at Children's Hospital of Pittsburgh, working with liver transplants of the very first transplant kids. After that, I did a lot of different hospital stuff. I landed at UCSF many years ago on 6 Long when I first moved to San Francisco. But after my first daughter was born, I landed at Noe Valley Pediatrics, where I've been grown roots, have become Nurse Judy, and I've been there for 30 years, kind of crazy. And Amy was mentioning she doesn't hear the vent. I don't hear screaming kids. So someone came to lunch with me the other day and they said, how do you stand this? I said, what are you talking about? And there was kids screaming in every single exam room, and I was like, Ma, I don't hear it. In the office, I do a lot of office seeing the kids. I'm on the phone with them constantly, and I do a lot of emails as well. And then somehow along the way, I started doing a blog, which just hit 209,000 site views. I'm famous for head lice and pinworms and poop and things like that. But when I moved to the office, what I found was the biggest adjustment was moving from hospital to office. And from the liver transplant, when the first jaundice babies came in, I thought they had biliary atresia, Wilson's disease. I was ready to send them to UC for the liver specialist, and it was like, whoa. So one of the first lessons I learned was, wow, most things are normal, and time fixes a lot of them. And I think when you're a pediatrician and you have a baby, or you're a specialist and you have a newborn, it's really hard to not go down the rabbit holes of all the different things it could be. And I also started doing classes, and I started doing a safety class many years ago, and that turned into an illness class, a solid foods class, all sorts of things. But the one I'm going to talk about now is the baby boot camp. And the reason I'm bringing that up is because I found that the parents who take the baby boot camp are way different from the parents who don't take the baby boot camp. So my question was, and I don't know how to move this, see, I need a kid.
If you push the right arrows.
Okay, perfect. So at the boot camp, I'm teaching the parents, it's prenatal education before the babies are born, and we're just talking about all the normal things that are going to happen for them. And what I found is that about a quarter of the patients take the boot camp, and the rest don't. And there's a huge difference between those families. So the ones who have taken the boot camp seem to do better, and they're not the ones who are calling me frantically and freaking out about everything. And the ones who haven't taken the boot camp they're just less prepared. And so that was the main thing that I want to talk about. So what's going on? Do you think that the babies of the parents who come to the boot camp somehow are less colicky? I doubt that. So my thought is, I'm going to use your baby because mine isn't here. So my thought is, at the boot camp, the first thing I say to the parents is, hey, guess what? You're in for a wild ride. 90% of you are going to have a terrible time ahead. The babies are going to be fussy. Your nipples are going to hurt. They're exhausted. You're exhausted. They're screaming. And you feel like you're the only person in the world who has this going on. You feel like, what's wrong with me? But you're the normal people. And 10% of the time, it's easy. So when they leave the boot camp, I always say to them, I wish you to be my 10%ers, but you won't be. And they've come back to me with the feedback, and they say it's so validating for them to know that they're normal. That's a big deal. And I think that if you have a mom who's calm and the baby's crying, they can pick them up and they could say, okay, I've got this, and I can take care of it. If you have a parent who's feeling completely overwhelmed and they're wrong and nothing's working for them and what's wrong with me, the baby's going to pick up on all this agitation, and I feel like having the calm parent and the tools to be calm makes a huge difference. The second thing is, at the boot camp I have a long list, and I'm not going to take all the time with you, is to go about what I teach the parents, like what are we talking about breastfeeding and what's in a mommy's diet and all the different possibilities of things that we can do fixing them. And so at my table, anyone who wants to come over there, we'll talk about Plan A. What do we do with the colicky babies? What are all the different things, including sending them to Amy to have her study them, or to a GI person. But if they know what the tools are, right away they can say, okay, I'm going to go ahead and I'm going to massage them, or I'm going to dance with them, or I'm going to give them some gas drops. And instead of a half an hour later of the baby screaming and going down, getting worse and worse and worse, they immediately have their plan, they have their tools, and they take care of it. So I feel like there's a big difference between, getting a hold of these parents early and giving them the tools that they need before the baby's born, and then they seem to do a lot better. So anyway, thank you for having me, and I'll leave the doll.
Thank you. And now we have Dr. Elizabeth Rogers.
Thanks so much to Paige and to Amy for inviting me to talk with you all today, and for all of you for being here. Just like children are not just small adults, my area of expertise is in prematurity, and preterm babies are not just small full-term babies. And so I think that this provides us with a really unique opportunity, sort of a window into a population where we know that the brain is developing slightly differently. It may not be injured, but we certainly know that maturation after preterm birth is a trajectory that is not always typical. And so maybe this particular population can give us a window into crying and what it means in terms of representing a developmental pathway. So what can we learn about the difference in crying characteristics and duration after preterm birth is one of the questions that really keeps me up at night. No, I'm just kidding. Again, my area is prematurity. I also run our high-risk infant follow-up program, so I see our preterm babies after they go home, and I'm able to sort of field a lot of questions from their parents about what is different for my baby? What am I going to have to look at differently than if I had just been born at term and went home? Instead, I spent 1, 2, 3, 4, 5, 6 months in the hospital, and how do I have to treat my baby differently, if at all? We know that a fetus actually develops all the motor abilities required for crying by approximately 20 weeks gestation. Certainly those of you who are ICN nurses know that when we are resuscitating a 24-weeker, they cry. Certainly the vocalization that comes along with the motor coordination is not always as strong, and it does take time, and usually at around term-corrected age, the actual vocal volume, etc., is usually almost equivalent to that of a baby born at full term. But many studies have shown that the actual crying of a former preterm infant has different characteristics and function. So it has a different frequency, has a much higher frequency than the frequency of crying of a full-term baby. And it's been shown in several different studies that the duration of crying before cessation for spontaneous crying is longer. Then for induced crying, there are similar differences that can be measured and have been measured. And folks have really hypothesized about what is the etiology of those differences. Why do they cry differently? So does it represent underlying brain dysmaturation, or does it represent potential underlying brain injury? So if Donna were up here speaking, she'd show you amazing slides of the preterm brain. And those of you who know me and have heard me talk before know that I have a couple favorites that I show, because from 23 up until 40 weeks gestation, at 23 weeks the brain looks smooth. It looks completely simple. By 40 weeks it is a complex, multiple gyri, sulcations, very complex. And so there's a lot happening obviously during that time. Even the difference between 32, 34, 36 weeks and 40 weeks is obvious if you're looking at a gross specimen of the brain or an MRI. So we know that there is still neurogenesis, there's synaptogenesis. We know that there's also programmed cell death that needs to happen in that third trimester. So a baby is supposed to be inside where it's dark and quiet, no stimulation, and instead we are putting in IVs and they're intubated. The nurses have to be checking their skin constantly. And every single interaction that these babies have with their environment can have an impact on all those normal processes that are supposed to be happening in the brain. So what we do when we're taking care of them in the nursery is we're trying to protect them so that we're not causing any more injury on top of them just being born early. And unfortunately, what we know about the difference in preterm babies is this can lead to a potential two-hit phenomenon for neurodevelopment. So there's biologic vulnerability. We know that there's acquired injury, both of the white matter and also hemorrhagic injury of the preterm brain. But then when they're crying and it's high-pitched and it's lasting a long time, and you have a mother who's been in the NICU for 4 months and is unprepared to take or feels unprepared to take her baby home, her ability to provide a high quality interaction that we know is so essential to brain development is limited. So maybe this is two hits. Maybe this baby is already vulnerable and now we're really compromising parent-child attachment. So what I'm really interested in is, can we use the different crying characteristics of a preterm baby as an early biomarker for neurodevelopment in preterm infants? So if we could do that, if this group today could define what is normal crying, what is a preterm infant's sort of normal developmental spectrum of crying, and then we can define from that what is abnormal, then we can put a sensor on when they're in the NICU. We can really harness technology, and we can consider how this might allow us to adapt the environment for the infant, to provide anticipatory guidance for families, and then potentially also get them earlier therapeutic interventions. So how can we learn more about this? I think there are a lot of different ways. First of all, just this group of folks coming together here and then bringing this message more widely. Community engagement, how this affects families and babies is important to understand, and we know that this needs to be transdisciplinary. So we need a whole variety of people to think about how we can do this. In terms of technology, can we develop an app Can parents do this at home? We certainly don't want every stressed out family with a preterm baby to have to come in and see Amy to be diagnosed, but can we, within their own home, utilize some technology to get a sense of whether their preterm baby or baby with brain injury might be at risk? So, thank you.
And our final speaker for today is Dr. Michael Cabana.
Good afternoon. Thanks for the chance to speak here today. I'm a general pediatrician. I conduct clinical trials, so I thought I'd give an update of some of the work we've done in terms of current probiotic trials and colic, which is related to this topic directly. Actually, although there's no room for disclosures or no specific slide for disclosures, I should disclose that I've been a paid consultant for BioGaia, which produces a specific probiotic used here. So according to the World Health Organization definition, probiotics are live microorganisms that, when given in sufficient amounts, confer a beneficial effect to the host. A specific probiotic that's been used, that's gained a lot of attention, is Lactobacillus reuteri, DSM 17938. So it's a specific strain of a specific probiotic of Lactobacillus reuteri. Starting in 2010, the first randomized controlled trial was published by Savino. That's in the second column here, which is it was a beautiful double-blind randomized controlled trial, infants who are breastfed. The dose was 10 to the 8 colony-forming units. The comparison was placebo, and it decreased crying time, and treatment success was considered positive. This was followed up by studies in Poland, a study by Kim Chow in Toronto, and then a study in China, which all showed similar results. The puzzling thing in 2014 was a study that was published by Valerie Sung using the same probiotic with the same dose, but didn't get positive results. What was wrong with the babies from Melbourne, Australia? Was there something different that happened south of the equator? We didn't know. So we had this string of positive results, and maybe this was just a fluke. In 2014, I noticed that all these authors were going to be at the same meeting in Aberdeen, Scotland. So we got all the authors together in a single room, and after getting to know each other, we had them all agree to actually do a meta-analysis, but not just a routine meta-analysis, an individual patient data meta-analysis. We actually had each of the investigators send all their data to an unbiased third party, the University of California, so the data was stored here and reanalyzed as one large clinical trial. These are some of the characteristics of the studies, and we thought by combining the data, we could maybe untangle what the reasons were for why some of this data was different in Australia. And that's our next speaker. This is some of the characteristics, and I'm sorry the formatting got changed a little bit, but there were studies from Italy, Poland, and Australia, as well as Canada, and it's the Australian data that was just a little different. So we combined all the data and reanalyzed it, and here's what we found. This is the change in day 7, day 14, and day 21, and when you combine all the data, there's a significant decrease across all types. But what's different is with the breastfed babies, and I apologize about the formatting, there's a significant result throughout the whole time period. But for the formula-fed infants, there is no significant difference. And if you look back, if you look at the Australian babies, they allowed babies that were formula-fed, so yet another reason to breastfeed as long as possible. And also the babies were a little bit older. If you look at that fourth column, 7.4 weeks of age versus about 4 weeks of age. So if we know colic self-resolves, there's just less time for it to work and to show a difference. So by combining the data, we were able to show a difference and where those differences existed and where the open questions still exist in terms of the research. And then this is just another way of showing the different data. There's a significant increase that occurs and it's sustained. And so for all my colleagues who say, Cabana, why are you studying colic? This is something that self-resolves. The difference here was 40 minutes. We've been in this meeting for about 45 minutes. Imagine a baby crying for basically the duration of this meeting. This would be very distressing to a family, so it's a significant problem. And this is how it shows graphically over time. There's been talk that the probiotic changes the gut microbiota or changes the the microbiota system. It happens too quickly. So one of the other theories is that L. reuteri DSM 17938 acts on a specific receptor, the TRPV1 receptor. It's a receptor-gated ion channel opened by capsaicin. So if you've ever had a red hot chili pepper, the reason why a hot chili pepper is hot is capsaicin. And TRPV1 provides a sensation for scalding heat and pain. And the theory is that L. reuteri DSM 17938 acts on this receptor and seems to block this receptor. One of the questions that was asked to me, what are the holdups or what are the research clinical gaps or hurdles that we'd like to address? Right now there's no clinical trials in the United States. It's actually very hard to recruit parents to participate in clinical trials on colic. Not too many parents want to have a 50% chance that their child will get a placebo. So that tends to be a little bit of a holdup. The other thing is, can you also use L. reuteri for prophylaxis for colic? So when babies are born, instead of waiting until they develop colic, would it be beneficial to give babies L. reuteri DSM 17938 right at birth for the first 3 to 4 months of life? You're saying, that's crazy, that's never been done. But it actually has been done and it's been published. This is a study that came out of Italy by Flavia Indrio. The sample size was 600 babies, and they showed that by giving this probiotic early in life, prophylactically, it could decrease the incidence of colic in the treatment group versus the placebo group. So those are the two questions. Do we need a study like this in the United States? And instead of treatment, is this something that would be worthwhile to consider in terms of prophylaxis? The downside is that you'd be treating a lot of kids who wouldn't eventually develop colic. So that's one thing to consider. And I'll stop there. Thank you very much.